today we're starting our new unit, Unit 2. It's going to be a lot of proportional relationships, what we're talking about right now, and then we're going to go more into functions. So right now it says, this graph says, only the top runners in the world can finish a marathon in close to 2 hours. This graph shows the pace that one such runner followed in a race. What is the unit rate? So just take a look at this graph and think, like, what does it tell you? What is the information that's given to you? How can we use that to find the unit rate?
What is a unit rate? Sounds like we hear that word and we kind of know how to calculate it, but what is it? Okay, so it's the amount, because it's not always going to be money, right? But your idea is correct, for one. So it's the relationship to just one whole. In this scenario, what do you think a unit rate would be? If we have the distance and we have the minutes, what unit rate might we be looking for? So examples of unit rates are like miles per hour, miles per gallon, dollars per bag, whatever the unit rate could be. It changes, depends on the scenario. What about this scenario? What may our unit rate represent? We're not looking at the number yet, just what it represents.
Talking about a runner. So what do you think a runner in a marathon, what do you think would represent the unit rate?
The times and miles.
So we are comparing time and miles. So how do you think we could break out the unit rate? What per what?
Miles per time.
Per what is our time in terms of like the unit?
Hours, minutes.
Well, that one is minutes. So we could say miles per minute. Right? What else could we represent? Let's get someone else. How else could we represent it? Miles per minute. What else could we do? How else could we represent it? Miles per minute, or? Well, here we only have minutes, but you are right. You could do miles per hour. A runner would be most likely miles per minute, because in terms of running, like the speed, it would say in a minute. But if I wanted to compare miles to minutes, could I compare it the other way? Yes. How would you say that? Instead of miles per minute, minutes per mile, right? Which is actually, if you're talking about a runner, that's typically how we represent running, right? Like I run, and yesterday I ran 8 minutes and 50 seconds per mile, right? So that's minutes per mile. You could do it that way as well.
So what are the coordinates on this graph that are given to us here? Points A and B.
So why did you say 20 and then 4? Because what? Okay, and then look at how it was written on the board in the parentheses. Why do we have to do the 20 first in this scenario? Why does the 20 have to be first? Think about graphing and what we remember about graphing. Why is the 20 first and not the 4? We represent our coordinates x and then y. So this is really important. This is a big source of confusion, because a lot of us don't remember that our x-axis is the horizontal, the straight across, and the y-axis is the up and down.
So you were kind of right, because you said time and then distance. So the time is actually, this is the x-axis, and then this is the y-axis where distance is.
Perfect. Are there any other coordinates on that graph that we know? Lewis gave us one. Oh, no. Giovanni gave us one, right? 20 to 4. Sorry. Jared, what's another one?
40 to 8.
40 to 8. Good. Do we have any others? Lewis, you can give us one.
16 to 12.
60 to 12, good. Any others? Go ahead, Jack, what's another one?
80 to 16.
80 to 16, good. Does anyone see any patterns? Because the patterns are where proportional relationships really sink in for a lot of us. Do you see a pattern? Everybody take a look. Really look at those 20 to 4, 40 to 8, 60 to 12, 80 to 16. What's your pattern? They can be divided, but let's talk about the pattern in their growth. Like when we go from 20 to 4, and then we go to 40 to 8, and then we go to 60 to 12, and then we go to 80 to 16. Which ones?
Like 20 and 4 because we do 4 and
4 and 5. Okay, you're actually, I understand what you're saying. Yeah, to go from the 4 to the 20, you multiply by 5. To go from 8 to 40, you multiply by 5. To go from 12 to 60, yeah, that's definitely one of the patterns. Does anyone see another pattern?
The time is adding 20, and then the distance it's adding by 4.
So my time, if I increase my time by 20 minutes, what's happening to my mileage?
It's growing
I'm doing how many more miles?
20 more. No, 4 miles more.
Good, 4 more. That pattern is really the basis for proportional relationships. So we should all see one of those patterns because they're both actually saying the same thing, which we're going to get to in just a minute.
So how do you interpret, how do you interpret these points? We kind of just talked about this a little bit. How do you interpret these points in terms of like the miles, like in context with this graph? How do you interpret these points? This one, 40, 20, or sorry, 20, 4. How do you interpret these in terms of the graph? Like, what does that mean? What does 20, 4 mean in this scenario?
Time and distance.
Be more specific. We use the numbers.
In 20 minutes, they ran 4 miles.
Yeah. In 20 minutes, they ran 4 miles. Could you tell me just based on that how many minutes it took for 1 mile? It took 20 minutes for 4 miles. So how many minutes for 1 mile?
5.
How do you know?
Because
So let's look at that ratio if we wanted to compare minutes to miles. So we have 20 minutes to 4 miles, right? And then we need to figure out how for 1 mile. So we use the big 1. And what's our big 1 here?
4.
We're going to divide both by 4. Good. So you can see the 20 gets divided by 4, and the 4 gets divided by 4, because that's a big 1. And then it gives us 5 minutes for 1 mile. And Marilyn, that's actually the pattern that you called out before, because you said to go from 4 to 20, you would multiply by 5. So for every 4 miles, each one is 5 minutes, that would have got you to 20. That's where her pattern really comes in.
So what is this called? What is that? What's that called? Okay, so it's saying it's 5 minutes for 1 mile, but what is this called when you're comparing it to 1 mile? What is that called?
That relationship compared to 1. The unit rate.
The unit rate, exactly.
Yeah, you were thinking the number. We meant more like the relationship. Good.
Oh, so we're kind of that on the rate per minute.
Let's stay on this. Right. So we just found minutes for 1 mile. Can we find the reverse? Is it possible to find out, and I want, before we go through the calculation, is it possible to figure out how many miles this person can run in 1 minute? Do you think we could figure that out? So it's 5 minutes for 1 mile. Do you think we could figure out how many miles they could do in just 1 minute? Do you think it's possible to calculate that? Yeah. Well, let's break it down. Is it going to be more than 1 mile in a minute?
No.
Why?
Because if you do 5 divided by 5, it equals to 1, and then it's gonna be 1/5. I think.
Why would you divide by 5? Marco's onto something. So our relationship right now is we know it takes 5 minutes for 1 mile. Right? So if I only run for a minute, I can't possibly run a full mile if it takes me 5 minutes to run a mile. Which, by the way, 5 minutes for a mile is like really, really good. That's like my dream. Okay. So why did you divide by 5?
Because to get 1, you need to divide it by.
To get what? And I'm gonna cut you off. I'm sorry to do that. To get what to be 1?
To get 5 to 1.
Yeah. So if you take a look at the board there, we have 5 minutes. We want that to become 1 minute. Right. So our ratio, we're going to somehow get from 5 to 1. We can divide by 5. Which means if we're talking big 1, we have to do the same thing to the denominator. So our minutes will now be 1. And what is our mileage going to be? 1 divided by 5. How can I represent 1 divided by 5? Does it need to be a decimal?
Yeah. Or it can be a fraction.
I can represent it as a fraction. How would you show 1 divided by 5?
1/5.
1/5, yes, very simply 1/5. A lot of us are taking extra steps to convert these fractions to decimals. You don't need to do that. That's wasting time. You can stick right with the fraction because 1/5 is the same as 0.2 or 2/10. It's the same thing. Good.
So now what is this telling us? I'm gonna put this into words for me. This right here. What does this mean? 1 over 1/5. What does that mean in this scenario?
No, we already know it.
You go on 1 mile when
Think about how it's labeled. How would you label that? The 1 and the 1/5. How would they be labeled? Remember.
You can run 1/5 a mile in 1 minute.
Perfect. You can run 1/5 of a mile in 1 minute. And think in context. If I know that I can run 1/5 of a mile in a minute, then 2 minutes is 2/5 of a mile, 3 minutes is 3/5 of a mile, 4 minutes is 4/5 of a mile, and then 5 minutes is 1 mile, which is the relationship that we already figured out. Those unit rates really are telling you the same thing, just in reverse.
So we already found the unit rate.
We already did that
So
too.
we already did that. Okay.
Let's go back actually and just look at the graph. Because where would I look on the graph to find the unit rate? Let's say the unit rate we were looking for was the number of miles for 1 minute. Okay, so look at the labeling on the graph. Miles for 1 minute. Where on the graph would you look? What values are you looking for? Can you see the unit rate just by looking at that current graph, or do we need to find the point somewhere on that line?
You can in middle of 0 and 20 put lines to represent numbers.
Break this up.
And what would we want what number on our x-axis are we looking for to find our unit rate?
1.
Yeah, if our x value is 1, and let's see why this works, because, I'm sorry, let me borrow that. So 4 to 20 is how much to 1? If I divide both here by 20, which is my big 1, then that's my 1/5. So on this line, and it's way zoomed in here, when x is 1, y is actually 1/5. At every point on that line fits the same relationship. So we're going to do an activity that Ms. Kay's going to introduce in a minute, and you'll see on the graph that some of them you'll see the unit rate, and others you'll have to find it.
Okay, so everybody's gonna get one paper. And what you're gonna do is, don't go ahead, you're gonna put your name on it. And then at the very top, we actually have to split,
Oh yeah, we need
Some
groups
of
of
the-
no larger, Yandel, do me a favor, bump back over there. We need 4 or less.
okay, so why don't,
So this, oh, you know what, the 2 of you bump over here, it's actually better when we have 4. You can go back when we're done.
okay, so the very first thing you're gonna do is put your name on it, and then at the very top it says intro. And what you're gonna do is you're gonna predict, is for the NFL, MLB, NBA, and NHL, you're gonna predict in order from least to greatest what you think, who makes the most amount of money a year and who makes the least amount of money a year.
So just based on what you know about sports or just in general, what organization? So NBA is professional basketball, NFL is professional football, NHL is professional hockey, and MLB is professional baseball. Who do you think makes the least amount per year in order? So like from least to greatest. Just write your guess. You don't have to look at the graphs, you don't have to calculate, just what do you think? Because then after the activity, we're going to go back and see if you were right. So write your guesses at the top in those 4 little lines.
Okay, and then as soon as you finish with that, what we're gonna do is you're gonna solve the very first graph.
Number 1,
Individually.
top left.
Yeah, number 1. Individually, by yourself, no talking, you're gonna find the unit rate and what it means in context of that scenario.
So think about what we did when we went through the example with the runner, and we'll just go back to give them a little breakdown, right? If we looked at a graph like this, we had 2 options, okay? We knew the coordinate, 4 miles in 20 minutes, and we used a big 1 to get this to 1. Sorry. Or like Marco said, if I look at the graph, I might be able to find where my x value is 1. So as you are going through to find your unit rates, those are your options. That's how you find the value for 1.
Okay, so do not go ahead because after you finish that first graph, we're going to give you a couple minutes to do it. What you're going to do is you're going to pass your paper clockwise. Everyone knows which way is clockwise? Okay, so you're going to pass your paper clockwise, and then you're going to discuss as a group, you know, if you agree, disagree, if you all got the same things, different things, how you feel about what your partner might have gotten, and we're going to give you about a minute to do that. And then with the paper that's in front of you, it's not going to have your name on top. Whatever paper is in front of you, you're going to solve the second graph on that person's paper. And we're going to keep doing this. We're going to pass and keep doing until we've completed all 4 graphs.
So by the end, you will have written on everybody else's paper at your table. Now, the group of 3, and there's only one group of 3, you're going to actually end up with your own, so you'll answer on your paper the last round, because there's one less person. But the groups of 4, it actually lays out perfectly. At the end, you will have written on everybody else's paper.
Okay, so we're going to give you, actually,
Does anyone have questions before we start? So again, looking at number 1, you are going to find the unit rate, the value. This for 1, whatever. Right? And then you're going to write what that means. Right? Because it's more than just like 7 to 1. Right? Well, it's 7 to 1. If I'm talking about miles per gallon, it's 7 miles for 1 gallon of gas, which would be an awful, awful car to own. So keep that context in mind.
so go ahead and start the first graph.